In a groundbreaking event for the United States Space Force, United Launch Alliance, ULA, successfully launched its inaugural operational Vulcan rocket on Tuesday evening. This mission marked a significant milestone as it was the first flight of a new launch vehicle that is set to eventually take over from ULA's Atlas V and the now retired Delta rockets. The Vulcan rocket, standing at an impressive 198 feet tall, was equipped with 4 solid-fuel strap-on boosters to enhance its liftoff power. At precisely 8:56 p.m. EDT, the rocket's 2 BE-4 engines, which run on methane, roared to life, propelling the vehicle away from Launch Pad 41 at Cape Canaveral Space Force Station. As it ascended, the Vulcan created a stunning visual display against the night sky, with nearly 3 million pounds of thrust generating a brilliant exhaust plume that could be seen from miles away. Approximately 90 seconds after liftoff, the 4 strap-on boosters were detached, followed by the burnout and separation of the Vulcan's first stage about 3.5 minutes into the flight. The mission then transitioned to the Centaur second stage, which ignited its 2 hydrogen-fueled Aerojet Rocketdyne RL-10C engines. However, in accordance with military protocol, ULA ceased its launch commentary at this point, and the remainder of the mission was conducted under a veil of secrecy. It is believed that the rocket carried at least 2 satellites, one classified and another experimental satellite designed to test advanced atomic clocks and navigation technologies. These innovations could potentially enhance the accuracy and resilience of Global Positioning System (GPS) data for both military and commercial applications. Both satellites were destined for a geosynchronous orbit located 22,300 miles above the equator, where they will appear stationary relative to the Earth's surface. In contrast, traditional GPS satellites orbit at a lower altitude of 12,500 miles. The Experimental Navigation Technology Satellite 3, NTS-3, will utilize a sophisticated phased array antenna capable of electronically directing signals to multiple receivers across vast areas. This marks the Pentagon's first foray into experimental navigation satellites since the initial GPS prototypes were launched in the 1970s. The NTS-3, developed by L3Harris Technologies, is part of a broader program that includes a ground control system and receivers that can be swiftly reprogrammed to accommodate upgrades or different signal types. GPS has become an essential part of our daily lives, often in ways we may not even recognize, remarked Joanna Hinks, a senior aerospace engineer at the Air Force Research Laboratory in New Mexico. With NTS-3, we will be exploring various technologies to ensure that GPS continues to evolve and meet the needs of our military personnel. While the primary objective of this launch was to deploy the USSF 106 payloads, it also represented a significant achievement for ULA. This flight was the third for the Vulcan rocket, following 2 test launches last year, and it was the first to receive certification from the Space Force for carrying high-value national security satellites and other military spacecraft. Gary Wentz, ULA's Vice President of Government and Commercial Programs, stated this mission is headed directly to geosynchronous orbit and will be one of our longest missions to date. This vehicle was specifically designed to support these missions, performing direct injections to geosynchronous orbit for the Space Force. A Vulcan rocket is set to replace ULA's retired Delta family and the well-known Atlas V, which has relied on a Russian-built RD-180 engine for its first stage. The use of Russian engines for launching American military and NASA satellites has faced criticism, leading to increased congressional pressure for a new, entirely American launch vehicle. Currently, ULA has 13 Atlas V rockets remaining in its inventory, all designated for civilian missions as the company transitions to an all-Vulcan fleet. Meanwhile, SpaceX continues to dominate the global launch market with its highly successful Falcon 9 and Falcon Heavy rockets, which are partially reusable and powered by kerosene. As of this year, SpaceX has completed 97 Falcon 9 launches. However, ULA President and CEO Tory Bruno emphasized that the Vulcan's first stage, featuring high-performance BE-4 engines from Blue Origin, founded by Amazon's Jeff Bezos, along with its powerful Centaur upper stage, makes it particularly adept at launching heavy military payloads into challenging orbits. This rocket is specifically designed for those unique orbits that are primarily for government use, he explained. This mission exemplifies that, as it involves a direct injection to geosynchronous orbit, which is a long-duration mission. Bruno elaborated that the first stage effectively delivers the Centaur into space with a full propellant load, enabling it to travel from low Earth orbit to the geosynchronous belt, which is significantly higher. This capability translates to increased mass and precision compared to other launch vehicles. He pointed out that while he did not mention SpaceX or its Falcon Heavy directly, the typical three-core heavy launch vehicles, which are often derived from designs optimized for low Earth orbit missions, require 3 cores to reach higher orbits, consuming all of them in the process. Here's the crux of the matter. 1 core is more cost-effective and efficient than 3 expendable cores. It's as straightforward as that, he stated. This efficiency, combined with the high-energy Centaur upper stage, allows ULA to launch substantial payloads directly into high orbits without necessitating that satellites use their own thrusters and limited fuel during transit. Looking ahead, ULA is expanding its ground infrastructure and anticipates launching 9 missions in 2025, aiming to achieve a cadence of 2 launches per month by the end of that year. The company projects a total of 20 to 25 launches in 2026.